So in the previous video, I talked about texture analysis and the co-occurrence matrix. Now that we have the co-occurrence matrix, we could find some interesting properties that derives from the co-occurrence matrix. There are four properties that we're looking for. We're looking for energy, entropy, contrast, and I can't pronounce this word. Homogeneity. So let's look at each of the properties. So the most important one is entropy. And is defined by P is our co-occurrence matrix. It's simply defined by the negative sum of P I J, which is our co-occurrence matrix, and we take the log of this co-occurrence matrix. So entropy, the word entropy means like chaos, stochastic, and the patterns are not consistent. So this property measures how stochastic this co-occurrence matrix is. So if this co-occurrence matrix is smeared out with values almost consistently across, then you can say that the texture is very stochastic, not regular. So it's not like a man-made nice and neat pattern. On the other hand, something that's almost inverse to this property is energy. And energy is the sum of P squared, the co-occurrence matrix. So this almost doubles the values of, so adding up all the values in the co-occurrence matrix and then square it, so this value is going to be a lot bigger than this one. And what happens for this one is you will have a co-occurrence matrix with one entry that is very high and the rest of the entries are very low. So if you think about a chessboard would have a white block and a black block. And this pattern happens over and over again. So in the co-occurrence matrix, you would have a one cell that is much higher than the rest of the grid. So the intensity, if you look at the image intensity, you would have very high levels on a bright spot, and very low levels on the low spot, and then nothing else on any other intensity levels. So energy, so when a texture is very uniform and consistent and replicates over time, then you will have a very high energy property. Then the rest, we have contrast, which is not as important, but so these are all sums, and it's I minus j squared p I j, and this will look at simply the contrast of an image, contrast of the textures of an image, and then we have homogeneity, which we have not gone thoroughly in class. So I actually don't know what that property does. So a couple of things to note with the co-occurrence matrix. First of all, it is not symmetric, and the elements of the co-occurrence matrix are normalized. And if you sum up all the entries, you would get up to 1. So next we went through a different method, and this method is called gray level run length method. but I'm gonna make that in a separate video because I like my videos to be short.